Very good morning to everyone. So continuation with the switching network part. The another way of switching which happens in the network is through the packet switching. Already we have discussed about the circuit switching in the previous video lecture. So the next part of switching which happens in the network is through the packet switching. So how this packet switching is occurring in the network is here we can able to divide the data into the packets which is of the fixed or and the variable size, and then based upon the size of the packet which is determined by the network and then the governing protocol, we can make this the packet switching network to be classified under the two categories, which is of datagram networks and then the virtual circuit networks. In the datagram networks, each packet will be treated independently compared to all other data packets. So and then this datagram networks operates at the network layer. Even if you are transmitting for a one packet, so if you are transmitting a single packet, so which is a part of the multi-packet transmission, so the network will be treating that single packet as though they existed alone, and then that packet what we are transmitting, even if it is of a single packet, it is a part of multi-packet transmission, and then the network will be treating that packet as an independent message. So each packet will be consist of a single message. We can travel from a different route towards to reach the final destination, and then these packets will be using the approach named as datagrams, and then this is about the datagram network which consists of three switches which takes place between the sender A and then the destination X. So how far your packets will be getting transmitted from a source to the destination with three different level of switches which explains in this diagram. And then the datagram network which consists of two main parts. One is about the destination address and then the output port. So all the packets will be having these two things: the destination address, that is the destination address will be available in the header part, and then the packets will be containing the destination address. So this destination address makes the each datagram to make how to forward the packet towards the final destination. So this packet header will be consisting the destination address, which will be in the form of the sequence number, so that it can be ordered at the destination. So we'll be having the sequence number along with the destination address, so which makes us to know that the which packet is delivered at the destination. And then here this diagram represents about the destination address and then the output port, and then how far the routing is obtained. So that also the clearly states. So sender is 1 and then the receiver is 4. So how far the switching takes place to transmit the data from the sender to the receiver, it shows about the packet transmission. And then here it shows about when we transferring the packet from sender to the receiver, so how the delay is occurring. So from A to B, when we are transferring the data packets, the delay will be occurring mainly from the switches which is getting connected towards the network. So this total time of delivery of packets to the receiver will be calculated, how much time it takes place in between the switches of when we are transferring the data packets from sender to receiver. This total time will be calculated as a delay. And then the next part is about how the connection is established. So this first we need to set up the connection. After setting up the connection, seamless data transfer is obtained, and then once if data transfer is getting completed, then it disconnects the connection. So this about the they're just comparing it with the circuit switch network. So how far the delay is happening in the circuit switch and then the packet switch network. So and then the next part coming to the packet switched is virtual circuit network. So before to that we have discussed about the datagram networks, which is also the packet switch network part. The another part of this packet switch network is virtual circuit networks. So the virtual circuit networks, which is an cross between the circuit switch network and then the datagram network. So this has the characteristics of both circuit switch and then the datagram network characteristics. So and then this virtual circuit networks operates at data link layer. The packets for the virtual circuit networks will be called as frames. So and then this is the diagram which represents for about the virtual circuit networks. So the sender and then the receiver. So and then we have the switches which is getting connected in between the systems of A, B, D and then C. So these are all the different end systems which is getting connected towards a network with the switches. And then here the virtual circuit networks, how it is getting framed with this virtual circuit networks is we need to have a special mention word, that is a virtual circuit identifier. So which knows for a special temporary address will be provided. So that is the virtual circuit identifier. So it will be this VCA will be at each switch, which used to advance the frames towards its final destination. So which means that all the switches will be having this VCA, so that the frames will be knowing that to which circuit we need to transfer it. That is for which switch it need to get transferred. So this is the information about the virtual circuit identifier. So here if you are having the virtual circuit identifier is 14, and then from here it obtains to the switch, and then from here then it will be moving to the identify the virtual circuit identifier of 77, right? That is your final destination. So and then this virtual circuit networks box consists of a table with 4 columns. So one is of a port, so incoming and then outgoing. So port number and then VCA along for the outgoing port along with the VCA. So to which port you are going to give an input, and then through which port you are going to get the output, which port you are going to get the output, and then along with the which virtual circuit identifier you are going to receive the output. So everything it will be available in the switch only. So the inputs of will be consist of port number and then VCA. Outputs of the output port number and then VCA will be there. So when we take this as an example for this virtual circuit network, so initially the frames consist of the VCA 77, and then the next frame is of 14. So it need to move to this switching part, and then finally it need to go to the output port of 22. So 22 it will be reaching, right? So after that again it will be reaching to the output port of 41. So this is what in the routing table with the switch it is obtained. So based upon this only you are going to make your packets to be getting transferred through this VCA. This about the diagram of source to destination, how the data transfer happens in a circuit switched network. So from the switch 14, which is of the incoming port, where you are going to send your frames, and then you are going to receive it to the output port of the VCA 66. So and then later in this switch the input is of 66 and then the output port is of 22. So you are going to deliver to the port of to the VCA port of VCA of 22. So in this switch part, the VCA from VCA 22, you are going to transfer the frames to the VCA port VCA ID of 77. So from there the data packets what you are transferring will be delivered seamlessly. So this is what happens in case of data transfer in circuit switched network. So and then the virtual how this a setup request in a virtual circuit network is obtained with the VCA is shown in this figure. So in this figure, so each switch will be having its own input VCA and then the output port. So but here the output VCA will be obtained based upon the request only. So VCN will be behaves like the circuit switched network, and it will be setting up the phase to establish the virtual circuit the identifier in the switching table. So based upon that only the data transfer will be done. So and then after setting up the virtual circuit identifier, then only the setup acknowledgement will be made in the virtual circuit network, and then we can able to transfer the data packets seamlessly from my end-to-end system. And then the delay in the virtual circuit network happens with while establishing the connection. So it happens between the switches of end-to-end system. So we try to minimize the delay by reducing the switching time which happens between the network. So and then this is a comparison chart for the circuit switching and then the packet switching. So orientation is for this circuit switching, it is a connection oriented. For the packet switching, we don't need the connection, so it is connectionless. Purpose is initially it is designed for voice communication, and then it is designed for the data transmission, and then the flexibility is it is inflexible. So once the path is set, all transmission follows the same path. But in case of packet switching, it is a flexible. It can create the path so that it can able to travel through that path to reach the destination. Order is messages received in the order, and here in the packet switching, the packets of message are received out of order. And then the technology approach, the circuit switching can be achieved using two technologies. One is a space division switching or the time division switching. But in case of the packet switching, here the datagram approach and then virtual circuit approach will be using. So what are the layers we are using in circuit switching is a physical layer, and in the packet switching we are implementing it in the network layer. So that's all about the packet switching network. Thank you.